from one end of the land to another. There is no more characteristic or familiar sight than the oil truck, making its round of deliveries to farms and factories, to homes and service stations. For in the highly industrialized society, oil and oil products play a great and ever-in part. Oil provides power and lubrication. It makes possible the operation of railroads and airlines, and it is the fuel which keeps traffic rolling. In hundreds of ways, oil vitally affects the life of every citizen.
Transport systems connect us, but that connection comes at an environmental cost. How can we radically change the way we move around the planet using more sustainable fuels, technologies and infrastructure? Welcome to Future Human, the series, the podcast where the team here at Silicon Republic explores the future of everything. I'm Anu D. This episode is all about the future of transport. But before we get to that, I want to tell you about our presenting sponsor, Hays. Hays is the world-leading expert in recruitment and workforce solutions, specialising in the professional and technical sectors and skills. Big thanks to Hays, whose support allows us to bring you an ad-free podcast experience. To access great advice and insights from Hays, visit haztechnology.com/blogs. We can't look at the future of transport without also looking at the future of energy, because engines need fuel and motors need electricity. Today, some 80% of the world's energy still comes from burning fossil fuels. And as was discussed at the sometimes disheartening COP28 this year, that comes at a huge environmental cost. Tilo Sucko is the head of sustainability at Sunfire, a German company that makes electrolyzers. Those are the devices that can make hydrogen. We'll learn more about Sunfire and the promise of green hydrogen later in the episode. But I wanted to start by sharing Tilo's perspective on fossil fuels, both from where he grew up and from his previous work at the World Wildlife Fund.
I come from a region in the southeast of Berlin that is basically very much dependent on lignite and brown coal for their energy consumption. And so my grandparents lived in that village and I spent a lot of time there in my childhood. But also half of my family was also dependent and codependent on those fossil fuel jobs. And some of them literally worked for the very power plant that basically ate up my grandparents' village. So I was a little bit ambivalent, and our whole family is about that. And I started realizing that every kilowatt hour, every product we consume that is being produced comes at some environmental cost. And then I also learned that the climate crisis very much also affects and even increases pressure on biodiversity loss, and is this why it's also interlinked with the biodiversity crisis. And so at the WWF, I focused a lot also about the impact of our eating habits. So the carbon footprint of our food system, basically our global food system. And then it appeared to me, and I learned that aside from this energy transition we need to go through as a society, we also need several transitions, actually. It's the transition of our food system, how we produce food and that kind of food that we produce. The mobility transition, we need to get rid of fossil fuels there as well, and so on, going up until how do we heat our homes and cool the places that we live in. So this multitude of crises and challenges intrigued me really, and I decided even before that I want to spend my professional life, not only my personal life in trying to reduce my personal footprint, but I also wanted to increase my professional handprint in a way that I'm contributing meaningfully to positive change in the world for the better.
We all have a carbon footprint, and the idea of creating that positive handprint to help balance out our negative footprint makes a lot of sense. The concept of this kind of handprint was developed by Shaun, the Sustainability and Health Initiative for Net Positive Enterprise at MIT and Harvard. The idea is that we find ways to grow our handprint more than our footprint so that we do more good to the planet than harm. Tilo is just one of so many professionals out there determined to make their mark when it comes to radically changing how we tackle climate change. We'll be chatting to Tilo again later about his company's mission to build a world without fossil fuels. But before that, we wanted to explore that first thing that comes to mind for most people when they think about the future of mobility, and that's urban transport. Urban transport is the sector that gets the most attention and has probably experienced some of the most and greatest changes in recent years. So how will we travel around and between our towns and cities in the coming years? Public transport will continue to play a key role, but radical new solutions are also a key part of the story. Things like shared electric bikes, scooters and cars are changing the way we travel already and what traffic looks like in our urban spaces. But it's very clear that we still have much to learn. Jenny Darmody spoke with entrepreneur Judith Häberli about new approaches to urban mobility. Judith is co-founder and CEO of Urban Connect, an urban mobility company based in Zurich.
What have been some of the biggest disruptors, would you say, in the transport industry in the last few years?
On a global level, I would say probably the electrification as a number one, and then as a number two. And I think it is as relevant to have a sustainable mobility in the future is the sharing, like the move towards shared vehicles. Although we've seen a bumpy start, right? We've seen the e-bikes or the bike sharing that was a bit of a fail in many cities. I think there is certain waves of sharing approaches, and I do think the future will also be shared, but probably looking a bit different than it does today.
Vehicle sharing is, of course, a crucial part of the transport sector, but there have been challenges for the companies supplying these services. Take shared e-scooters, for example. There are discussions in lots of cities at the moment about how they should be regulated, whether they should have speed limits, should they have designated parking zones, and should they be used in bike lanes and on footpaths. In April 2023, the people of Paris were invited to vote in a referendum on rented e-scooters, and a cool 90% of them chose to ban them, making Paris one of the first cities to impose an all-out ban. So the three main companies there, who between them had a fleet of some 15,000 e-scooters, are now focusing on e-bikes. And even e-bikes aren't without their critics. Even though they're fast, they're often used on footpaths and without safety helmets. So how do we go about regulating industries like this? Back to Judith.
I mean, there is regulatory issues that we're seeing now today in the B2C space. We're, like, as a company, not affected by it, but we can see many startups especially suffering from cities like Paris banning them because of, like, understandable reasons, I believe. Like, they do lie on the sidewalks and they do replace a lot of walking instead of, like, driving with the car. So we've had a big learning curve in the sharing industry, I think, from, like, understanding that maybe hub-based in cities works better than just complete free-floating and you can leave the scooter or the bike wherever you want. I think the move, like the development goes into more like station-based sharing because it is a bit more structured. It is better for the visual of the city, but also for the users, that they know that there's a reliable place where they usually can find shared vehicles such as micromobility. And then the other thing is the car mobility, where I think a privately owned car is like, you see the price not just for mobility. You pay the price for status, you paid for freedom. My personal opinion is that I do not think that B2C car sharing can be done in a profitable way. Many have failed. We have one company in Switzerland that is a cooperative that does it in a profitable way today. So yeah, it is possible, but it is not possible in a scalable way. I would say in Switzerland, we are a bit of a special ground because there is high income, very good public transport support. So many people, especially like here in Zurich, 50% of the population doesn't own a car. So this kind of car sharing, it works here, but I do think there needs to be subsidies in some form for car sharing and actually also any sharing, just as there is subsidies for public transport. I don't think public transport and sharing providers should fight against one another. They're doing the same thing to some degree. They're trying to optimize the amount of time a vehicle is being used or occupied. And we all want to reduce the amount of privately driven cars. I think public transport and sharing providers actually have probably very similar visions, and we should work together more. And we always have this picture of the cake or the pyramid where the base is public transport. And then if that is not possible, or the next option should be shared micromobility, like shared e-bikes, shared e-cargo bikes for transporting stuff or humans. It's like the food pyramid, like the sugar, the things we don't want to ban. It's nice to sometimes ride the car for a holiday, but it should only be used when the other options just don't make sense.
Just in the wider scope of the future of transport, do you see autonomous vehicles becoming part of the future of transport, or do you think that's still too far down the line?
I do think that I'm pretty sure there will be autonomous cars. I mean, there are autonomous cars today on the streets, right? They are there. I think 10 years ago, we all expected them to be there much sooner. And because of regulatory issues and probably some technical as well, but mostly regulatory issues, it's just going slower. It probably also allows us to reflect a little bit longer of how do we then once they're here, how do we want to use them? And I really hope we will not use them in the sense that people will move further away from work because they can now work in their car. I hope we use it in a way that we think about the citizens or the population in cities first and don't continue this thinking of building cities around cars and now try to think how can we build cities around autonomous car because more people will be moving from public transport into an autonomous car because it's so convenient. I really hope we will use it to reduce parking. We don't need parking in cities anymore, and parking takes up a lot of cities. In European cities, if you look at the whole surface of the cities, 30% is reserved in some form for cars, either streets or parking. And this, I think we should use it as a challenge to say, okay, the car drops me off at home and continues to ride to get the next person. It shouldn't then be also parked in front of my home. So that, I think, is a way how we can use autonomous vehicles to increase the livabilities of cities. I also think it should be used to have less traffic because they can talk with one another.
So as we've seen, the shift to relatively car-free cities is already well underway as more and more policy leaders strive to improve air quality, cut emissions, and encourage healthier and safer practices like walking and cycling. While emission cuts are often the motivating factor, imagine all the other knock-on benefits of cities with radically reduced car fleets in our future. The health benefits of cleaner air has got to be one of the big ones. London's ultra-low emission zone, the largest clear air zone in the world, covering every borough of London, aims to help the capital's 9 million residents breathe cleaner air, and the data is indeed promising. New analysis from the University of Bath found that cleaner air in the city contributed to a 4.5% reduction in long-term health problems and an 8% decrease in respiratory issues like asthma and bronchitis. But for me, the factor that often gets underplayed is the issue of sheer space. In New York, it's estimated that some 25% of Manhattan Island is given over to roads and parking. In a city where space is at an all-time premium, think of freeing up just half of that space for other infrastructure, from green spaces to housing to facilities for the community. It's why cities like Paris under Mayor Anne Hidalgo is planning to ban through traffic in the first 4 arrondissements, that's Parisian neighbourhoods, next year. That's some 7% of the whole city and indeed the main tourist area. Already over 900 miles of bike lanes have been created in the past 7 years, and the city turned 40 miles of its roads into bike lanes during that first lockdown during the pandemic. Hidalgo now aims to ban all diesel cars from the city by 2024 and all petrol cars by 2030. Paris plans to cut its parking spaces by a cool 50%, with proposals to use the reclaimed space for everything from play areas to allotments. A stroll around those smaller cities who have long bitten this bullet, Oslo, Ghent, Amsterdam, Helsinki, already give great food for thought about the future of our urban areas. But Paris is Europe's largest single urban area, so for me it's definitely one to watch for the future. If this works in Paris, well then why not everywhere? But moving along, another industry which is both impacted by and is heavily impacting our climate is, of course, the aviation industry. And frankly, it can sometimes feel like it's getting a bit of a free ride when it comes to climate action. First of all, it's interesting to look at how it is impacted itself by climate change. As the atmosphere changes, we might see more jet streams, which could make flying more difficult and complicated. As air temperatures increase, the density of the air will decrease, which will make it harder for airplanes to take off, so they'll need ever longer runways and more fuel to get off the ground. And we certainly don't want to add more fuel to the equation, because aviation is, of course, a major contributor to climate change. And it's not just about the tons and tons of aviation fuel. I spoke with aeronautical engineer Sarah Qureshi. Sarah is the CEO and co-founder of Aero Engine Craft, which is a Pakistan-based business looking at those other aircraft emissions rarely acknowledged by the aviation industry. But we started by talking about why aviation is such a crucial player in this energy transition.
It's the only industry operating in the sky, and we know it's a very critical industry. We can't do without it. I mean, with now the world becoming so connected and we being used to be so connected. When we talk about the Earth or our planet, on ground there are many industrial contributors to global warming and to CO2. So the contribution is widespread, but so is the awareness. Because it's so widespread and it's so visible. It's not like something happening in the sky at 1 kilometer above us that we cannot even see, let alone understand. So there is like this public pressure or this public consciousness about global warming and sustainability on the ground. And because there are many industrial contributors, there are also many contributors to mitigate it and to look at ways on how this problem could be addressed. And there's so many technologies that have come forth across the spectrum of industries. But there's a limit to what can actually be transposed in the sky. So I would say, number one, it's hidden. Number two, we cannot grow trees there. I mean, there's no way to offset it. I mean, it's been proven, there's a scientific consensus, and it's been proven that emissions from aeroplanes cause global warming. I particularly work on contrails. Contrails is this white smoke that's behind the aircraft, and that is frozen water vapor. It's called a condensation trail, because when you burn fuel or hydrocarbon fuel, you get carbon dioxide as well as water vapor. So these are the two main contributors to environmental pollution in the sky due to aircraft engines. So there's carbon emission, which is 50% of the emissions, which is carbon dioxide. And when we say zero carbon, it only means that you are looking at carbon dioxide. And zero emission means that the remaining 50% is the contrails. And there has always been more focus on carbon dioxide, and the reason is because carbon dioxide is also something that is produced on the ground, because when fuel burns or any fossil fuel, hydrocarbon fuel burns on the ground, again you get water vapor and carbon dioxide. But because we are very low, we are at relatively higher atmospheric pressure, and within the weather cycle that water naturally recycles itself, whereas in the sky we are at quarter of a pressure of what we are here at ground, and the temperature is very, very low. So this water vapor does not become liquid water or rainfall at that altitude, because weather cycle is until 2,000 meters. Airplanes like long haul airplanes operate at 10,000 meters. So when this water is emitted in the form of steam, as it enters the cold atmosphere, it freezes into an artificial cloud, which is called a condensation trail or a contrail, and it manifests itself as like a line of white smoke behind the aircraft. Now, this contrail then just disperses into induced cirrus clouds, and that are not capable of creating rain. They are at very high altitude, and because they are artificial clouds, they are disturbing the Earth's budget. So the radiation budget is disturbed, and so you get this phenomena. It's like a blanket gradually covering the surface of the earth, and you get this phenomena of global warming and climate change and greenhouse effect. So this is the problem. This is what we have to address if we want to make aviation sustainable.
So contrails or condensation trails form when the hot moist exhaust from the jet engine hits the cold air. They look small from the ground, but they can stretch for miles and they can stay there for hours. They form clouds that trap the Earth's heat. This is especially a problem for contrails that linger at night, when they trap heat from the Earth but they don't deflect any heat coming from the sun, which during the day helps balance it out a little.
So when we talk about emissions in the sky, we always talk about carbon dioxide, and then we try to transpose some of the technologies to mitigate carbon dioxide. But that still is half the solution, because we need to understand that water vapor, when released at an altitude of 10,000 meters, is a greenhouse gas. It's a vapor. It's not like rainfall. So we need to understand that difference first. But because contrail is a phenomenon which is very specific to the sky alone, nobody's talking about it, because the aviation industry considers it like a penalty on themselves, that they would need to make cleaner engines, new engines. But we have these examples in the automotive industry, and there's a lot of equipment that's fitted in the cars which has nothing to do with the performance of the car. It is there just to comply to emission regulations, and the manufacturer is paying for that. The consumer is paying for that. So there is an example that could be used for the aviation industry. Number one, the first thing is that it has to come under regulation. Emissions due to aeroplanes, due to aviation, must be under some regulation. At present, it is the only industry which is exempt from emission regulation.
So we need better regulation of the aviation industry. Airlines must be required to produce lower emissions. New technologies will be an important part of that. I was very interested to learn more about a specific piece of technology that Sarah has developed to address that problem of contrails.
Research on contrail emissions has been going on for quite a long time. It started during World War II because, enemy planes could be detected. But then later, they were just detecting contrails, and later they realized that it has a global warming impact. And we came up with this invention, which is like an add-on to a jet engine. It's like a hardware device. What it does is that it processes the exhaust emissions and converts the water vapor content, because the exhaust emissions have carbon dioxide and water vapor both. Water vapor content into liquid water, so that you eliminate the source of, you're not releasing that water in the atmosphere to form contrails. So you eliminate the source of global warming in the sky. I've done it as a prototype on a small scale, and then I'm trying to raise funding for the next level.
We're unlikely to see an end to aviation in our lifetimes, so hardware innovations and green fuels, in my view, are urgently required. I'm of the somewhat Luddite view that drone deliveries and flying cars are somewhat of a distraction as we strive to make future mobility planet-friendly. It is the massive sectors like aviation and shipping and manufacturing that need our attention, and fast. After an arduous and sometimes discouraging negotiation process, the world's governments agreed on a deal to transition away from fossil fuels at that recent COP28 UN climate conference. Today, burning coal, oil and gas accounts for 75% of our greenhouse gas emissions, making fossil fuels the largest contributor to climate change by far. As we strive for net zero by 2050, what are the renewable alternatives? Well, one might be green hydrogen. So back to my conversation with Tilo Sucko.
So Sunfire is a company that produces electrolyzers. Electrolyzers are machines that basically separate water into hydrogen and oxygen, and they do that using electricity. And if that electricity is renewable, generated via wind, solar, whatever kind of renewable energy source, then you can call this hydrogen coming out of this electrolyzer green hydrogen. It's a game changer because hydrogen can do so many things. It is not new, however. There is already a lot of hydrogen demand that's being produced fossil fuel based out there in the world economy. But with that, there's a huge potential to really replace that fossil fuel based hydrogen with renewable hydrogen. So that's one big climate impact right there to get rid of all these emissions. And then hydrogen as a molecule is very versatile. You can use it in products. It's being used in chemical products. It's part of basically every fuel that is there, which gives green hydrogen the opportunity to actually create green fuels, sustainable air fuels, for instance, or for long-haul shipping. So you basically have those hydrogen molecules and pair them up with carbon molecules that have been ideally extracted from the atmosphere or have somehow been captured from a renewable source. And then you just do some chemical magic with it, and then you end up with sustainable fuels right there. In sectors actually that are really hard to transform any other way. We are not going to have all the air fleet that is out there globally. We are not going to have those on batteries and fly 100% electrically. Same with ships. And so this is one aspect. And then green hydrogen has a huge potential to also defossilize and decarbonize industrial processes that are still fossil fuel based, like steel making. And so if you would get rid of those coking coals that are used to reduce iron to make steel with green hydrogen, you are going to save a lot of carbon emissions there. And this is also what the steelmaking companies globally are going to go through if they transition to net zero emissions.
A 2022 report by the International Energy Agency found that demand for hydrogen as a fuel is only growing, but that almost all of it is still generated by fossil fuels. Making hydrogen requires a lot of water, of course, and it's expensive, but the final product contains about 3 times as much energy as the same weight in petrol. So is it worth it? And if we can make it from renewable energy, is this where we need to focus our energy? If you'll forgive the pun.
Actually, it is a one-in-a-century opportunity for, well, first of all, for the European Union to really support this upcoming green hydrogen economy and to be a technology leader. This is a market that is rapidly developing all over the world. The global installed capacity of electrolysis is just a couple of 100 megawatts. And in the EU alone, it is going to be 100 gigawatts at least until 2030. At least that's the political target. So you see what the magnitude of the scaling challenge is just by the sheer numbers to increase more than 100-fold in the next 7 years and just in Europe. So it's a huge opportunity, but also a huge challenge. So the hydrogen economy, just like any other, freshly built up and ramped up economy like the renewables back then, starting with no numbers of output and low numbers of gigawatts installed, the economies of scale are going to produce the same picture there. The costs are going to fall for green hydrogen and for electrolyzers as well. So this is just a typical scale-up curve, if you will, for the green hydrogen economy. And of course, at some point, green hydrogen is going to be cheaper than its fossil fuel equivalents.
This is an exciting and complex time for transport. A sustainable future for transport is going to involve new fuels and renewable energy sources, new technologies to capture and process emissions, new ideas to make travel more efficient and sustainable, ways to make our cities more livable, and policies that keep us on track as we aim for net zero. And while technology and innovation have a huge role to play in the energy transition, what we need more than anything else is the human factor. At a personal level, we have to continue to adapt our behaviours. If you live in the city centre, do you really need to own that car? Here's an unpopular one. Do you really need 3 foreign holidays in a year? Could that meeting be a video call? Or if you're part of the 1%, do you really need to own that luxury jet? At a policy level, we need leaders that make brave, radical, and sometimes expensive or indeed unpopular decisions that pay off in the longer term, something we do not have a great history of. Many of the technologies and innovations that are required are already at our fingertips. Now, what we need more than anything is the human will to ensure they're urgently deployed. This series is curated by the Silicon Republic team and produced by Shaun and Maurice. The interviews were conducted by myself and Silicon Republic editor Jenny Darmody. The podcast is part of Future Human on Silicon Republic, and for more great content, from filmed fireside chats to deep dive articles, visit siliconrepublic.com future-human. Thanks again to our series sponsor Hayes, the experts in recruitment and workforce solutions.